Assalamualaikum and good day to everyone. Today, we will present about the topic differences between Unix and Windows. There are 7 aspects for differences between Unix and Windows. First, inter-process communication. Second, process. Third, threads. Fourth, CPU scheduling. Fifth, synchronization. Sixth, memory management. And seventh, file system. But first, let me introduce our team members. We have Nur Farisha Izzah binti Yusri. Second, Nur Naili Nabiha binti Subuh. Third, Nur Izzati binti Muhammad Nasir. And me, Nur Ayuni Nabila binti Ma'asri. Let's begin with the introduction. Unix is a multitasking, multi-user, and portable operating system. It was designed for adaptability, flexibility, and portability for many types of devices such as desktop, servers, and laptops. It's said to be portable because it can run on different hardware architectures. It was multi-user because many types of users can use it at the same time. For Windows, it's a graphical operating system. It allows users to store and view files, run software, and connect to the internet. So without further ado, let us hear all the presenters discuss about this topic.
Thank you, Aini, for the explanation. Since we already know what is Unix and what is Windows, now we can start with the first differences of Unix and Windows, which is inter-process communication. What is inter-process communication? It is a mechanism used by a process to communicate with other processes, such as sending or receiving message or data, and to synchronize their action. This communication between these processes is a method of cooperation between them. There are many available inter-process communication, such as pipe, socket, several and many more. Unix and Windows uses a common RPC, such as pipes and shared memory, but with a different implementation. This can be seen by the command used. They use a slightly different command. We can take pipe as an example. In Unix, to create a pipe, we use pipe command, while in Windows, we use create pipe command to create the pipe. Other difference is pipes in Unix support only unidirectional data stream, while in Windows, it supports both unidirectional and bidirectional. Other RPC methods used in Unix are message queues and semaphores, while in Windows are main slots and remote procedure calls (RPCs).
Thank you, Farisha. Now we proceed with the next aspect, which is process. In Unix, multiple processes can run simultaneously due to the multiprocessing capabilities of the Unix operating system. Every process has a separate address space in multiprocessing, and CPU can be added for increasing computing power. Meanwhile, in Windows, it supports multithreading, which divides a single process into numerous threads to boost processing speed. When a process is multithreaded, multiple threads of it run concurrently while sharing a single address space. The next difference is process creation. In Unix, a new process is created by the fork system call, which creates a copy of parent process. On the other hand, in Windows, a new process is created by the create process function, which creates a new process based on a stable file. Last but not least is process isolation. Unix uses process group and session for process isolation. Meanwhile, in Windows, it uses job object and the process tree for process isolation. That's all for process. Now I will pass to the next presenter.
Thank you. So now I will continue the presentation to explain about the differences between Unix and Windows operating system in terms of threads. In Unix, the threads are implemented as lightweight process, which is LWPS, and are managed by the kernel so that the threads share the same system resources and memory space as the parent process. This allowing for speedier synchronization and communication. Meanwhile, in Windows, it uses the kernel level threads, which are managed by the kernel of the operating system, so that the thread has their own system sources and memory space, which might result in greater overhead and slower synchronization and communication. Furthermore, in-thread scheduling on Unix system is often handled by a user-level scheduler, which provides for more fine-grained control over thread scheduling, while Windows it uses a kernel-level scheduler, which may provide less control over thread scheduling. Typically, in Unix system, it offers a more robust threading library such as pthreads that offer a wide range of functions. So the example of function is for managing, creating, and synchronization thread, as well as support for real-time scheduling policy, compared to Windows, which has more restricted threading API, which provide a more limited set of functions for threading. So that is the difference between Unix and Windows operating system in terms of threads. So now I will pass the presentation to the next member. Thank you.
Okay, now we proceed with the difference between Unix and Windows operating system in aspect CPU scheduling. The first difference is scheduling algorithm. Unix uses a priority-based scheduling algorithm where more CPU time is allocated to tasks with a higher priority. In contrast, in Windows operating system, it employs more advanced algorithm called the scheduler, which consider a process priority as well as its most recent CPU utilization. The next difference is time sharing. In Unix, it requires additional time sharing to provide each task with the same amount of CPU time. Meanwhile, Windows also uses time sharing, but it is not as dependable as used in Unix. The last difference is symmetric multiprocessing (SMP), which allows many processors to work on various processes concurrently, supported by Unix. On the other hand, Windows also supports SMP, and also added support for non-uniform memory access, also known as NUMA architecture in later version. That's all from me for CPU scheduling. Now I will pass to the next presenter. Thank you.
Thank you, Izzati. Now we're going to look for the fifth aspect, which is synchronization. In Unix, it depends on atomic file operations to avoid conflict. If several processes attempt to access the same file at the same time, the kernel will ensure that the file is updated automatically, which implies that the file will be changed completely or not at all. Meanwhile, for Windows has a file locking mechanism to prevent several processes from accessing the same file at the same time. A process in Windows can lock a file, which prevents other processes from accessing it until the lock is removed. For backup and recovery in Unix, it utilizes tools like Resync. It is well known for its delta transfer method. Instead of copying everything anew, the efficiency is accomplished by transferring only the section of the file that have changed. Whereas, for backup and recovery in Windows, they use the built-in backup and restore software such as Microsoft OneDrive. It's embedded into Windows system and may be used to generate and recover backup of files and folders. While Unix and Windows has their own sets of tools and methods for file synchronization and sharing, their implementation differs. So that's all from me. I will pass to the next presenter, which is Farisha, to explain about the seed aspect.
To continue this presentation, I will explain about memory management in Unix and Windows. Memory management is used in operating system to manage all operations done by both primary memory such as main memory and secondary memory such as disk during every process execution. It is needed for many reasons such as to allocate and deallocate memory before and after every process execution. Both Unix and Windows use virtual memory to extend the memory availability from the available physical memory to make it larger. The difference is Unix implements a unified virtual memory system, which every process shares the same virtual address space, while Windows implements a separated virtual address, which means every process has their own virtual address space. Unix uses combination of sweeping and demand paging, while Windows primarily use paging. Unix memory management is simpler, less fragmentation, and uses flat memory model, while Windows memory management system is more complex, risk of more fragmentation, and uses a segmented memory model.
Thank you. So now we continue presentation to explain about the last differences, which is in terms of a file system. For Unix, the file system follow a hierarchical tree-like structure with the root directory and the top-level directory. Meanwhile, in Windows, it primarily uses a NFTS, which is stand for New Technology File System, that follow a hierarchical structure, but it uses a drive letter to identify each partition rather than a single root directory. In Unix file system, it provides a more advanced set of permissions that enable fine-grained control over who may access and edit file. Meanwhile, in Windows, it has a simpler permission structure based in user account and group, and it is less flexible but more user-friendly. In Unix file system, such as ext4 and xfs file system, may handle file size up to 60 exabyte. Compared to the Windows and FTS, maximum file size is 16 terabyte. So we can see that Unix handle more size compared to Windows. And then in the Windows file system, it supports a file level compression compared to Unix, but Unix provide a different tools to compress files. So in terms of file system, we can say that both operating systems have their own advantage and disadvantage. So now we move to the conclusion. In conclusion, Unix and Windows are both operating systems, but they have some significant difference in terms of their design, functionality, and process management. So we can say that Unix has more advantage compared to Windows operating system in many aspects. As a more adaptable operating system, Unix may be set up of a wide range of devices, including mainframe, computer, supercomputer, and microcomputer. In addition, Unix require less administration and maintenance, and it is more reliable than Windows and does not fall down as frequently. Unix also has a greater built-in security and permission feature than Windows. Hence, as stated in each topic, there are many different aspects between Unix and Windows operating system. So, that is about video for today. Thank you.